Okay, number 26, again, my suspicion has something to do with what we've just done. So let me write this over here. F of x is equal to the arc sine. Now, it's easy to forget things, so I just want to go through a little derivation over here. So let's say y is equal to arc sine. All right, that means sine of y is equal to x. I want to talk about the invertible region over here. We got something like this over here. And I know the angle's got between minus pi over 2 and pi over 2. And I'm going to differentiate now, and this is going to be cosine of y, dy dx is equal to 1. So dy dx would be equal to 1 over cosine y, or secant y. All right? So what I'm looking at over here is, I'm looking at something that I don't like the way it looks. And what you were told to do in your pre-calculus courses was to rewrite this. And this is the angle. They use right triangles for it. And by the way, as long as I'm between minus pi over 2 and pi over 2, this is going to work out fine, because the cosine is going to be positive, or I should say non-negative. All right? So I'm going to write this down, and I'm looking at the ratio, and I'm looking at this over here. The sine of y is going to be x over 1. So this over here is going to be 1 minus, let's see, x squared, right? So the cosine of y would be this over here. So the secant of y is actually going to be, let's see, it's going to be reciprocal of that, right? So it's going to be 1 over the root 1 minus x squared. So I'm going to say that, basically, I think I can talk about the function now, all right? So if y is equal to the arc sine, you know what, I'm not going to use y. I'm going to go back to my eraser and get the eraser out. Back to f of x here. F of x is equal to arc sine of x. And I'm going to say f prime, and again, I'm trying to relate it back to what I know, is going to be, I'm seeing this over here, and that's going to be the derivative, right? We just did that. And it's going to be dy dx is secant of y. And we found the secant of y is going to be the 1 over the root of 1 minus x squared. So what I'm going to do is I'm going to write it down a little bit differently. I'm going to write it down as 1 minus x squared to the minus 1/2. All right? And that reminds me of that binomial expansion. And I need to rewrite a little bit differently. And let's put this one down over here. So f prime, I like the fact that I got the 1, but I need to write this an addition problem. So it's going to be 1 plus minus x. Yeah, I think I did okay there. And that's going to be to the minus 1/2 power. I think I'm ready to write down something over here. And someone says, what are you ready to write down? I guess I'm ready to write down the summation now. All right? So the summation, put this over here, n equals 0 off to infinity of this particular guy here is going to be what? Minus 1/2. And there's going to be an n over here. And then when you get there, you're going to get, let's see, you're going to get x to the, well, not x, I'm sorry, I made a mistake there, it's not x. Get my eraser out again. All right, it's going to be minus x squared to the nth power. All right, so let's take a look at that. Simplify a tiny little bit. And I'm seeing that this is going to be, let's write this down carefully, n equals 0 to infinity. I'm going to write down minus 1 to the n, minus 1/2 n, and this is going to be x to the 2n now. All right, I'm going to expand it, and there's a reason for that. I want to make sure that what I write down after this is correct. All right, so if I were to expand it, I'm going to get minus 1 to the 0 minus 1/2, 0, and then you're going to get, x to the 0, which is just going to be 1. So I'm not going to write that down. Then I'll put the next term down. What's it going to be? Plus minus 1 to the 1 minus 1/2 n, and then you're going to get x. I take its derivative, right? I'm not there. I'm sorry. It's going to be x to the 2. Sorry about that. I misspoke. And then you put the next term down. It's going to be what? Minus 1 squared. You know what? I made another mistake. I got to correct it. I think I'm just daydreaming. And it's going to be 1. So minus 1 to the square to 2, then minus 1/2. It's going to be 2, and it's going to be x. I'm at 2 now, so it's going to be 4. I think you get the idea that I could do this forever. Now someone says, what is that? That's f prime. I want to go backwards. All right. Now what do I want to do? I want to go back to the arc sine. So I'm going to integrate. So I'm going to integrate the left side. That's arc sine of x plus c. I just integrated. I got to integrate the right side now. And what do you get? Minus 1 to the 0 minus 1/2, 0, x. Let's do the next one. It's going to be plus minus 1 to the first power minus 1/2, 1, and this is going to be x cubed over 3. Go to the next one. Plus minus 1 squared minus 1/2, 2, and that's going to be x to the 5 over 5. And I'll say yada, yada, yada. Right? All right, I think I'm ready to write it down now. And I'll write down what I think I'm saying, which is this over here. I'm going to start at 0. I'm going to go off to infinity. I'm going to say minus 1 to the n. Let me point out what I just accomplished here. I accomplished getting this thing covered. Let me do the next one. What's the next thing going to be? Minus 1/2 n. What did I accomplish over there? I got this thing covered. Now let's do the next thing up, which is this x to a power over a number. And I see that as well. I'll write this as a quotient, x, and that's a 1, and it's going up by 2. So I'm going to say 2n plus 1 over 2n plus 1. Let me see if I've accomplished that. And by looking at that, I'm certainly getting the exponent 135 and the denominator 2. All right? So let's talk about the interval of this guy over here. And I think we did the binomial before, right? And it's between minus 1 and 1. So now my x squared is still going to be between minus 1 and 1. So the x is between minus 1 and 1. And I think we're done. Thank you.